Hello viewers and learners of the program Postgraduate Diploma in Environmental and Occupational Health and Master of Arts in Environmental and Occupational Health. Welcome to this session on Chemicals and Health. This forms a part of the course MEV 004, that is Environmental Toxicology. Now chemicals are everywhere, so they're even present in our bodies, and some of the chemicals are vital for our body's functioning. For example, we take sodium chloride or salt in our food, in our diet every day. We also consume iodine, which is very important for the functioning of the thyroid gland. In the same way, bananas, they are a rich source of potassium, and potassium is very important in the regulation and functioning of the heartbeat. So we have seen that these chemicals are vital, they are important for the human body's functioning. On the other hand, there are other chemicals that include the mercury, lead, arsenic, cadmium, chromium, and there is a long list to it. So these chemicals are not good for health and they are hazardous. Now, talking about the importance of the chemicals, have you ever wondered how life was before the chemical age? So in the ancient times, speaking of the infections, many of the people were getting infected with typhoid, cholera and various other waterborne diseases and pathogens, and this was because there was also a lot of people died due to these diseases, and this was because there were fewer pharmaceuticals and the medicines that were available to treat these diseases. Therefore, the higher mortality and morbidity rates were seen then. So despite better living through the better chemistry, we still are actually afraid and we fear the exposure to the chemicals. So some of the chemicals are really bad, they are toxic for our health. For example, we all know that we should not inhale the gasoline fumes when we visit a petrol pump or a gasoline station. In the same way, we all know that we should not drink or consume the laboratory chemicals or those that are used as the cleaning agents in our domestic or in the workplaces. So therefore, some chemicals are bad, they are also hazardous for health. Now there are other chemicals, even in a very low level or a low dose, they can cause endocrine disruption and hormonal imbalances can occur, and because of that, that can even be passed down from generation to generation. So therefore, this giving an overview of the chemicals, their importance and also some of the hazardous chemicals, let us now understand what is a chemical. So chemicals can be very simple. For example, you have water, you have the molecules that are there in the air. So water, this consists of 2 hydrogen atoms and 1 oxygen atom, that which is seen in this figure, or it can also be very complicated like the antibiotic amoxicillin. Now, a chemical can also be defined as a compound of substance that has been purified or prepared, especially artificially. So they can be prepared synthetically in the laboratories. Now the categories of the chemicals. So as we said, we have the natural chemicals and we also have the synthetic chemicals that are produced in the laboratory. Naturally occurring are like the water, carbon dioxide, nitrogen compounds that are part of our everyday metabolism, breathing and also excretion. Synthetic or the prepared ones, as you see these colored liquids, they are actually industrially prepared in the laboratories. So how are we exposed to the chemicals? Now, whenever we are exposed to a chemical, like for example, it could be a location where there is a use of a chemical, for example, fracking location or in fracking operations, or some of the byproducts of the oil drilling which is getting into the groundwater. And then contamination in these water supplies, that could be taken up by the organism, especially the fishes, and then it could be brought to us through the edible fish. Now, whenever we are exposed to a chemical, there are some questions that should always crop up in our mind. These are, how are we exposed to the chemicals, and how are these chemicals getting absorbed into our body, or what are the routes of exposure to these chemicals? Then, we should also understand how these chemicals are distributed in the body, how they are being metabolized in the body, and finally, how these chemicals are being eliminated from the body. Now, many of the chemicals, if you see, they can be relatively, eliminated from the body by the kidneys through the urine, but there are some chemicals which are not eliminated easily. For example, lead comes under this category. So lead can remain in the body. It could be stored in the body, especially lead can be stored in the bones of the humans. And this can also lead to devastating neurological effects, and that can also bring about the neurological hazardous effects in the children. So therefore, the lead toys and all the lead kind of things that are used at home, that should be avoided. Also, another thing which comes to my mind when we talk about the fish. So there was one report in 2023 which came, that was about the fishes in the lake in Michigan, in Chicago, and here it was seen that the fishes were exposed to hazardous forever chemicals. And one of the scientists who was from the Liverpool, the John Moores University in England, he said that these are one of the greatest threats to the humankind. So why do we say this? Because they said that these fishes, they were actually the freshwater fishes which were there in the lake over there, and they contained PFA. That is the per or the polyfluoroalkyl substances. These are actually used in the clothing. They are used in the non-stick pan. They are also used in the furniture. So this was a direct transmission from the fishes to the human beings, how this PFAs could be transported directly into the human body. So this was of concern, and here the scientists reported that that was 278 times there was more PFA that was found in the fish, which was biomagnified. And the fishes actually normally, the bottom dwelling fishes, they accumulate more of the chemical because the chemicals settle down to the bottom, the benthic region, and the fishes normally go to feed at the bottom of the lake. So the bottom dwelling organisms will contain more amount of the chemicals since the chemicals are settling over there. So these are some of the examples that I have given, and when they mean hazardous forever chemicals in this 2023 report, they say that one serving of the locally available fishes from that place, that was equivalent to having contaminated fishes or contaminated water for an entire month. So you can see the graveness of the situation and how toxic those fishes would have been. Now, another question that comes to our mind is, can a newborn baby, can a newborn infant be exposed to a chemical through his or her feeding bottle or the bottle where they drink the milk or the water and so on? So very few people, even now when you visit the stores like Mother Care or any other store, very few people will suspect that the bottle should be nice, the baby should be able to hold the bottle, and the nipple should be soft, pliable, comfortable for the baby to drink the liquid. But then very few people would realize that this contains a plasticizer and that has some kind of a chemical off-gassing, and they expose the baby to phthalates. So phthalates are hazardous. Then the kind of coating that is used, the polycarbonate material that is used, that contains a substance called as bisphenol A or BPA. So this bisphenol A is, again, it is formed by the condensation of acetone with phenol, and it is used in the production of polycarbonates. And then there was an outrage by the manufacturers when the people found out that there is bisphenol A in the bottles, in the baby bottles, and then they replaced this with the BPS and BPF, which is nothing but the bisphenol F and bisphenol S. But again, they are the derivatives of the bisphenol, and this bisphenol, they are basically xenoestrogens, or they mimic the estrogen in the body, and they affect the reproductive systems of the laboratory animals. So they do bring about the endocrine problems and the endocrine disruptors and hormonal imbalances. So, having given you some examples, how do the chemicals in the environment get into our bodies? This is really a cause of concern, and there was one leading news which came or which made into the national headlines in West Virginia, where there was a leak from a chemical industry into the river that led to a drinking water supply. So this was the Elk River, This is a tributary of the Kanawha River that is in Charleston in the US state of West Virginia, and this spill occurred on January 9th, 2014 when crude 4-methyl cyclohexane methanol, this was released from an industry into the Elk River. Now here again, this was a toxic chemical, and 5,000 gallons of this chemical was introduced into the river, and people were advised not to drink this water, not to bathe into this water, not to wash their clothes or wash their dishes in this water. So the complete water supply was blocked, it was closed, and the restaurants were closed. So again the situation was grim. So there were lots of concern about the multiple pathways of ingestion, about the exposure. So here we are understanding the term routes of exposure. So that means ingestion of this water or even absorption of that water on our body. That is why people were refrained from using this for any kind of activity. So from this we understand that the routes of exposure are also equally important. So what happens when the chemical enters the body? They can enter the blood, they can enter the lymph cells within the blood, and metabolism begins there and it begins to break down. The liver begins to work, it starts detoxifying, it starts mixing with the bile, and then the body compartmentalizes them for storage. Now this is what happens in the case of DDT. So the DDT can get stored in the fatty tissues in the body. In the same way, lead can also be stored in the body. So some of the chemicals are lipophilic, in the sense that means they love fat, they are fat loving, and they can be stored in the fatty tissues. Others goes to the kidney, where they can be they could be excreted relatively quickly through the urine, but some others may not be relatively excreted so quickly. So from this we understand that we have a very efficient system in our body, but when the chemical enters the body, then it can exert certain effects. It could be distributed to the body, it could be distributed to the various organs, it might affect the cells. So therefore these terms absorption, distribution, metabolism and elimination are very important for us to understand. Now the two terms toxicokinetics and toxicodynamics, they appear to be large words to understand. So kinetic itself means movement. This is important. That is why we should understand how the chemical moves from the environment into the body, and in the body also from exposure to a dose, and to a dose that actually might affect the cells and that might start changing the biology of our body. Now toxicodynamics are the dynamic elements of our body or the person who is exposed to of the early biological effects. Now what do we mean by the early biological effects? They are the earliest changes to be noticed, right? So when you see that your hair is turning grey, or that you see that your eyes are turning red in color, so there are some minor changes, and the moment you start seeing these changes, these are very subtle changes that are found, that are being observed in the cells, and so getting from the internal dose to a dose that is manifesting, that is actually beginning to change the biology, and then that is also changing the function of the cell. That is very important. So here we are understanding the concept dose is important, right? So anything. Now for example, aspirin, if you take in higher amounts, more than the recommended dose, then that is toxin. In the same way, warfarin, which is a blood thinner, which that is again used for continued for a period of weeks and a long period of time, that can also result in internal bleeding. So therefore the dosage is very important, that even a normal thing can become a poison. And this concept was put forward by Paracelsus in 1400, and he is also known as the founder of toxicology. Susceptibility. Here again, the concept of susceptibility and tolerance is very important. So we all have a different biology, right? I have a very different biology from my mother or from my father, but of course there are some genes, some things which we have inherited from generation to generation, that would definitely be manifested in the genes. But we also have different susceptibility factors. For example, I may be having a kind of an allergic reaction. I may be susceptible to the fur of the cat, or I may be susceptible to the fur of a dog. I may be susceptible to cold and certain other infection more than others. So that means I am susceptible to something more than somebody else. In the same way, tolerances for things. So I may be tolerant, for certain things. For example, two people go and have a drink, for example, alcohol, it could be wine. So some of them could have a dizziness, or they could develop headache just by having one shot or even half a cup of the wine. But some others, the tolerance limit may be more. They can even tolerate even 2 cups or 3 cups, and they do not develop any dizziness, nausea, or any kind of a seizure. So that means the tolerance limit for both these two people are different. So some of us also have mutations which predispose us to certain diseases than the others. So this could be mutations that predispose us to cancers, also to certain other very important hereditary or very important diseases. So this way, human beings are different from each other. Right? We are very different from each other, and all these susceptibility factors, the tolerance and our genetics, they also define how the chemical is going to be manifested, what turns they take into our body, and how they will be metabolized in the body, and so on. So therefore, coming to this question, are chemicals good or bad? So all chemicals are not good, right? Because water is good, we are drinking water. There are the air molecules, which is we are breathing the air for our survival. So not all the chemicals are bad. Natural does not mean safe. In the same way, all green things do not mean healthy. Dose makes the poison, and which I said is attributed to Paracelsus, credited as the father of toxicology. So we have discussed that chemicals, they do give their effects. For example, they can bring about the hormonal changes. They can bring about changes in the metabolism. They can disrupt the protein synthesis. They can form reactive chemicals in the cells. Then they can produce DNA damage and epigenetic changes. They can interfere with nutrition and biochemical functions, and they can also alter certain physiological mechanisms. Now coming on to the toxic effects. So a toxic effects is normally categorized according to the site of action. Sometimes it might occur in one site, and which is termed as specific target organ. Now here in this figure you can see that a chemical can target specifically the heart, the brain, or the lungs, or it can occur at multiple sites, and it is called systemic toxicity. Now some of the chemicals that are causing the systemic toxicity, if we say that the toxic effects are due to absorption and distribution of a toxicant to a site that is distant from its entry point. So the potassium cyanide, this is a systemic toxin. It will affect each and every cell, and it will affect many organs, causing immediate damage and death. Now the classes of systemic toxicity, here they are the acute, subchronic, chronic, carcinogenic toxicity, developmental, and also genetic toxicity. Now, one example of the acute toxicity was that which was noticed in the Bhopal gas tragedy, which occurred in Bhopal in December 1984. And that is also known as the night of death, on exposure to methyl isocyanate, which was released from the Union Carbide India Limited, this pesticide plant in Bhopal in Madhya Pradesh. So this caused acute toxicity and also genetic toxicity, and that was passed down for generations to generations, and people are still victims to this. So that was because of the leak of this obnoxious gas, which where several children were afflicted, and that was a classic case of the chronic toxicity. Then we have some of the chemicals that were used in the World War I, predominantly the mustard gas. So this was introduced by the Germans during the World War I, and this is the dichloroethyl sulfide. It smelled like mustard or the horseradish. That is why the name is referred to as mustard gas, and it is an oily brown liquid and also known as the king of the war of gases. Why? Because this was used predominantly in the war. Now, what were the symptoms that were observed when the people were actually afflicted with this or they were sprayed with this mustard gas? So here we find that there was blistering of their skin, then their eyes were damaged, and they had coughing, runny and bloody nose. It affected the bronchial tubes. It triggered diarrhea, vomiting and fever, abdominal pain, and many other problems related to the gastrointestinal upset. Now, what are the chemicals that cause subchronic toxicity? This was the example that I gave of the blood thinner, and that can also result in internal bleeding when there is repeated exposure to a pharmaceutical or a chemical for several weeks and months. Now there are chemicals that also cause chronic toxicity. So this takes months or years to become an identifiable clinical disease. For example, the chronic kidney disease and also bronchitis, where long-term smoking is done by the people, and also the black lung disease, which is observed as the pulmonary fibrosis in the coal miners and the coal mine people. Then again, there are the chemicals that cause the developmental disorders and developmental toxicity. So these are the adverse toxic effects to the growing embryo or the fetus. So some examples are the lead and the mercury, and they can interfere with the development of the neurology, that is a brain. They can interfere with development of the brain, with the normal growth, differentiation, development and the behavior that are caused by many of the toxicants. Then we have some of the chemicals that cause genetic toxicity. So that means it results from DNA damage and the genetic material is being destroyed, and there is altered genetic expression. So this genetic change is called as mutation, and the agent that is responsible for the change is called a mutagen. So here in this figure, you can see chromosomal aberrations and mutations that can occur in germ cell and in somatic cells. Especially chemicals like chromium, cadmium, arsenic and nickel can bring about this. So you can see a normal arm of a chromosome, a single arm, and one part of the genetic material is duplicated due to, it could be due to radiation or it could be due to the exposure to chemical, and in the altered chromosome you can see that that genetic material is duplicated, or you can find two of those genetic material which is repeated twice. In the same way, deletion can occur where in one arm of the chromosome, okay, one part can be, the genetic material can be deleted. Why? Because breaks are occurring in that strand. Again, it could be due to radiation, due to ionizing radiations, also due to chemicals. So this deleted genetic material, when that is cut off, then the new chromosome, when it is formed, that is deleted, or it has a missing information, or it doesn't have that part of the genetic material. And this information or this problem, that the chromosomal aberration which is going on, that can be passed on from generation to generation, and the next generation, they will find that this genetic material is missing, or it is lacking or deleted in their genome. So genetic toxicity is a very big thing, and chemicals can cause havoc. It is really very hazardous where they are bringing about this developmental toxicity and also genetic toxicity. Now, the chemicals can also cause organ-specific toxicity. So that means a specific organ can be affected, like the benzene can target the blood-forming tissues, lead can target the cerebrospinal fluid, the central nervous system, the kidney, and also the hematopoietic system. Then in the same way, there are also certain chemicals that have brought about bone toxicity. A classic case study, an example, was that of the radium girls. 3 US factories was the site of these incidents: in Orange, New Jersey in 1917, Ottawa in Illinois in 1920, and Waterbury in Connecticut in 1920. Now here, most of the workers were the female workers and the girls, and they were instructed to paint the dials of the watches and the clocks with a luminous radium paint, and this radium paint consisted of powdered radium, zinc sulfide, gum arabic and water. Now, the women were also instructed to point those paint brushes containing this radium to the lips, and they also painted it on their faces, saying that this would give a glow to their face and so on. But it turned out that that was highly toxic, and at the age of 25 and 20, many of the ladies started getting admitted in the hospital, and after 5 years, 1925, Harrison Martland discovered that the radium which was there in that paint, that was deposited in the women's bones, that is hazardous. And from these newspaper cuttings, you can see that one lady who was a mother of a child, she was only 25 years old, and she was affected with this when she was hardly 20 years old, and she died at the age of 25 with this radium poisoning. So this radium is deposited in the bones. It remains over there. It is hazardous. So that was a case study where the luminous radium paint was done by the radium girls, and they suffered. In the same way, we find neurotoxicity, where axonopathies like axon injury, demyelination, interference with neurotransmission can occur. Mercury, lead, uranium, and several agricultural pesticides are some of the neurotoxins. Domoic acid, again, that is also one kind of a kyanic acid type neurotoxin, and that causes the amnesic shellfish poisoning, and this is produced by an algae, and it accumulates in the shellfish, in sardines, in anchovies, and when the human beings or even the higher animals like the sea lions, they eat this contaminated animals, then the poisoning can occur. It affects the brain, and it causes temporarily loss of activities and seizures, and also possibly death. So this domoic acid, it was also found in 1987 in Prince Edward Island in Canada, and also recently in 2023 we find these reports. So this algae, Nitzschia pungens, was the source of this toxin, and domoic acid was a primary neurotoxin in Mytilus edulis that caused the poisoning in humans. Finally, we also find that there are several of the chemicals which cause reproductive toxicity. So they cause a damage to either of the male or the female reproductive system. For example, vinyl chloride and several industrial solvents, the cancer drugs, and also lead, cadmium, chromium, ethylene dibromide, all of them cause toxicity. So my dear learners and the viewers, in this session, we have discussed about the chemicals, the exposure to chemicals, how chemicals could be distributed in the body, metabolized, and whether these chemicals can be eliminated from our body, how do the chemicals actually get inside our body, and what are the effects that they have shown, with the examples of some case studies which have occurred in the past few centuries, and then we find that how they can cause the different organ toxicity at the specific levels, and how hazardous chemicals can be to human health. I hope you have had a good understanding of the same. Thank you for your patient listening.